The networked file system. In this nugget, we're going to talk about the network file system. We'll talk about how to configure the network file system on the server side and the client side, and I'll point you to some resources so you can learn more about NFS and how to make it work as well as possible for your installation. So let's get to work. Alright, well, let's start by talking about NFS, or the network file system. Now, the network file system is for allowing directories or file systems to be shared across a local network. Okay, NFS can be set up on a more global network, but it really isn't secure enough for that, and it really works well and saves a lot of work for system administrators to set it up on a local area network, so some network that's secure and sort of shut off from the outside world. Okay, so the way I've set it up here, pictorially, is that there's a server with a couple disks on it, and then there are a few client machines out here. Let's call the server Nugget Server, and the client machines like Nugget Client 1, Nugget Client 2, and so on. Okay, now the way that I've set this up is that the /home directory on this disk is exported to the 4 client machines. Okay, and then this miscellaneous Project X directory is exported to these 2 client machines. Okay, so now what will happen is when this client machine boots up, we can set it up so that it remotely mounts the /home directory on the server, and now that'll be the /home directory on the client. Actually, you can set NFS up so that the /home directory here gets mounted as, /junk on the client. Okay, but that's not such a good idea. Okay, just from an organizational standpoint, if it's called /home out here, call it /home here. That just makes your life easier as a system administrator. Just makes it easier to keep track of things. Okay, so as long as the server's up and running, then this client has access to the /home directory. What kind of access does it have? Well, that's up to the server. When the server the way that the server is configured, it could give this client, read-only access to this directory, or read-write access to this directory, and so on. Okay, same goes for the Project X directory. On the server machine, there's a configuration file that determines which client machines get to access Project X, and also how they get to access Project X. Alright, so now let's talk about how to configure NFS. Let's start by talking about how to configure the server side of things. Okay, so first thing you have to do from the server side of things is select which file systems that you want to export. Okay, so here's some candidate file systems or directories that you might want to export, like /home, okay, or /var/mail, /user. Okay, so /home makes it so that if you export the /home directory to all the various machines in the network, then the user can then log on to any machine, and the user's home directory will then be accessible from any of those client machines. Okay, var mail for the same kind of reason. You can get your mail on some central machine, and then if you log on to any of the client machines, you can read your mail because the var mail directory has been mounted on that machine remotely from, like, the Nugget server machine. Okay, /user is another example for libraries or binary executable files. Okay, and from a system administration standpoint, it makes sense to share these file systems that have executables in them, for instance, because then you install software on one server machine, and then all the various clients mount that directory remotely, and then they get access to all that software you installed. So then when you want to go to do an upgrade, you just upgrade it on the server machine. Everybody is running now the new version of the software. If you just want to do an installation of some piece of software, you install it on the server in like /user bin or something like that, or user local bin, and then everybody on the network has access to that software that you just installed. You don't have to go around to all the various client machines and install it individually on each one. Okay, so from a system administration standpoint, NFS can save a lot of time, and from an organizational standpoint, from a system administrator, it just keeps the system administrator from pulling his hair out and going crazy trying to keep track of what machines have which software and so on. Now, there's a few rules that you have to follow for the server configuration. One is you can only export local file systems. So if some server here exports a file system to this client machine, the client machine in turn can't export it to some other client machine like C2 or something. Okay, so this is against the rules. The server machine that houses the file system that actually has the disk that the file system lives on is the one that chooses which machines can read that remotely. Okay, it can't give access to C and then the C machine gives access to C2 to read that directory. Okay, another rule is that a directory and a subdirectory cannot both be exported unless they reside on separate disks. Okay, so if they reside on the same disk, just export the directory, the subdirectory will come along with it. Okay, but if they are on separate disks, then you can export them individually. They can both be exported in that case. Okay, now a couple other things with server configuration. This configuration file is called etc exports, and the format of that file looks something like this. And this is sort of right out of the info page or the man page. It starts with a directory. Each line of etc export starts with a directory. This is the directory that we're going to export. Then it's followed by a host that we're going to export it to and a set of options. Okay, now the stuff in the square brackets here, anytime you see that in a man page or an info page, that means that stuff in the square brackets is optional. Okay, so for this particular directory, I have to give one host at least that I'm going to export this directory to, okay, and a set of options for that. I can list other hosts. Additionally, I can list as many hosts as I want for that directory. Okay, now the options, here's some common options, and there's a whole bunch of options. Just check out the man page or the info page if you want to do something tricky or specific. Here's the common options that you would see in this field, in the parentheses after the host. First one is RO versus RW. So RO says the host has read-only access to this directory, and RW in there would say that the host has read and write access to that particular directory. Now, note here that if I export like the /home directory, for instance, I need to give read-write access to that directory, because if I want people to be able to write to their home directories, I need to give read-write access to the /home directory. This doesn't mean that any random user can write to some other user's home directory. Okay, just because I've given read-write access for the NFS share, okay, or the exported directory, doesn't mean people get read-write access to everything. There's other Linux permissions that are still in place. User permissions and group permissions and things like that are already set up, and they will enforce everything that we've already talked about with regards to permissions. Okay, so I can't just go ahead and access somebody else's directory if it's not owned by me or if I'm not in the right group, even if I have read-write access to the share that it lives in. Okay, so this is just the first condition to give write access. The other conditions also have to be met. I have to be either a user, the owner of it, or in the right group, and so on. Another options that you might see in here are async or sync. Okay, one of these two options you might see in there. Now remember the sync command from a few nuggets ago, when I think it was the Linux rescue nugget. We talked about the sync command, which forced memory writes, or writes that were going to disk that was being buffered in memory. It forced those to be written out to disk. Okay, async says we're going to allow caching of those writes. So if some client machine, the client machine sitting here, and it's writing out to memory. Okay, so here's the memory for the client machine, and it's really writing, it's saying, okay, I'm writing this change to disk, but what's happening is it's buffering in memory, and then when NFS sees fit, maybe when you've written enough data, then this will go over the network to the server machine and write to the disk on the server machine, only when this buffer gets sufficiently full. And that just makes the network traffic sort of more minimized and more efficient. Okay, so the advantages of async here is that the network traffic is more efficient. There's fewer requests over the network for data to be written to the server's disk. The advantage of sync is that you know that the client machine's writes are written out to disk immediately, and so the server machine's disk is up to date as possible if you have sync. Okay, so you might want sync for, if it's some critical application, maybe like a banking application or something like that, you would want all of your writes to be synchronized so that this disk has the most up-to-date information on it, so that if some network goes down or some computer goes down, all the stuff that was in memory there has already been written out to disk. Okay, another option you might see in here is something called root squash. Root squash is actually the default option. If you wanted to disable root squash, you would write no root squash, like no _root_squash. Okay, root squash, what that does, the default action says that no added privileges on the are given on the server machine for a root user on the client machine. Okay, so out here on the client machine, I'm the root user. Okay, and I mount this particular directory remotely from the server machine. That does not give me root access to that directory on the server machine. I only have root access to my local directories. Okay, I do not get root access automatically to the directories that I mount via NFS. Okay, and this makes sense, right? Because somebody might need root access on their particular client machine to set up various privileged things, like networking things or whatever, right? But that doesn't mean that you want to give them root access to the file system that you're mounting remotely. Okay, so that's why root squash is the default. We do not give those root privileges to root users on the client machines for the server directories. If you set it up as no root squash, then if somebody has root access on the client machine, they will also have root access on that directory that gets mounted, that file system that gets mounted remotely via NFS. Now let's just look at the etc exports file on my particular machine. And this is just a made-up file right now because I don't have NFS set up on my machine, but I just want to give you an idea of the syntax and some of the pitfalls that people run into by editing this file by hand. Okay, so I'm just going to open it up with the Emacs editor, and in this file, what I've done is I've created two particular shares, /home and /user. These are the two artificial entries that I've added, and these entries I've exported to all the computers that that match this format, star.mydomain.com. So any machine like a.mydomain.com and b.mydomain.com, all of those machines are going to have access to /home and /user as I specify here. Okay, so here what I'm doing is I'm saying that for home, every machine in mydomain.com has read-write access to the /home directory, and I've also set it up to be asynchronous access. Synchronous is the default for NFS. Okay, so if sync is the default for NFS, that means that every time I write something on the client machine, it's also written through and written to disk on the server machine. Okay, so that they're always synchronized. Async says that the machine can actually cache those writes, and so it doesn't actually have to go through and create a lot of network traffic. Okay, so that's what I've done for that particular share, for the /home share. For /user, I said for all the machines in mydomain.com, star.mydomain.com, I've given read-only access to the /user directory. Okay, so that's my etc exports. Now, one of the things you have to be careful of here is just say you did something like this. Say you wanted read-write access for all the machines in mydomain.com, but say I put a space in there. Okay, say the parenthesis didn't run right up to that. Well, now what this is going to do is it's actually going to have unintended bad circumstances, okay, bad results from this. So what's going to happen here is, because I put this space in, now what happens is for star.mydomain.com, all the default values, all the NFS defaults apply to star.mydomain.com. Okay, and the NFS defaults are things like read-only access, synchronous, root squashing, and all that sort of stuff applies now to star.mydomain.com. Now, because I've left this space, what that says is that all other hosts on my network are going to have read-write access, and they have this asynchronous flag set as well, the asynchronous option set as well. So all the other machines in the network have read-write access now to /home. Okay, so this is bad, right? Because what this is saying, this is doing sort of the opposite of what I wanted to do. I wanted to give read-write access to all the machines on mydomain.com, and what I've done is I've given read-only access to those machines and read-write access to everybody else. So you have to be a little bit careful when you're editing this. Make sure that you follow the syntactic guidelines for etc exports, because it's such an important feature. You're giving, exporting directories to other machines in the network, even though you're talking about local networks here. We're not talking about the whole internet. We're just talking about local networks, but even in that local setting, you don't want to give read-write access to machines that aren't supposed to have it. Okay, that sort of thing. All right, so that's an example etc exports file. Now let's talk about NFS configuration from the client side of things. Alright, well, to show you how to configure NFS from the client side of things, what I've done is I've bookmarked a couple of web pages that explain how to do this. Now, this is right out of the Red Hat Linux 8.0 manual from redhat.com. Okay, and the first way to mount an NFS file system is just to use the mount command. Okay, and the way that we do this, the syntax for this, is we say mount, we follow that by the NFS server name, followed by a colon, followed by the name of the directory on that server. And then we mount that locally, or the mount point is given next, /mis/local in this example. So the mis export directory from shadowman.example.com is mounted locally as /mis/local. Now this directory must be exported. It must be in the /etc/exports file on shadowman.example.com for this mount command to work. But if it's in etc exports on Shadowman, then it will be mounted as an NFS share locally as mislocal, and the permissions that apply to this directory are dictated in the etc exports directory or etc exports file on Shadowman. Okay, so that's one way to do things, is to just use the mount command. And this is fine if you're just using the mis export directory temporarily. Alright, if you're using mis export though every time you log into the system, then a better way to do things is to add an entry to the etc/fs tab file, which is the file system table configuration file. If you do this, then every time your system boots up, then the particular NFS share will be mounted on your system automatically. Okay. Now the syntax for the line that we add to etc/fs tab is like this, the grayed highlighted thing here. Okay. So again, we give the server name followed by a colon, followed by the name of the directory on that server. Then we give the mount point, in this case /pub. Then we give the file system type, and for NFS shares, that file system type is just NFS. Okay. Then these over here, this is just some parameters for NFS. We're going to talk about what these parameters mean in a few minutes. Okay, but this is the basic syntax for the etc/fs tab file to add an NFS share so that it automatically boots every time you log into the system. Okay, so that's another way to mount an NFS file system, is to add an entry to FS tab. The other common way is to actually just use the mount command, and like I said, this is for temporary usage of a particular share. Okay, another way that we can add an entry to etc/fs tab, or to mount an NFS file system, is to use the webmin interface that we've talked about before. And if I go to disk and network file systems, if I click on that, then what I can do is I can go to add mount, and then I can go in here to NFS and say click on add mount, and then it's going to add an NFS share to my system. Okay, so it's first asking, what do you want it mounted as? What's the mount point for the system? Okay, do you want to save and mount this at the boot time? Do you want to mount it now? Do you not want to mount it now? What's the host name that you're going to mount it from? What's the directory that you're going to mount from that particular host name? That sort of thing. And then there's some advanced options down here below. Okay, so this will create an entry in etc/fs tab. If you say save and mount at boot and so on, that's going to create an entry in etc/fs tab for you, so you don't have to go in and edit it by hand with like VI or Emacs or something. And that might just save you some problems with formatting and so on as well. Okay, or if you don't remember the exact format for an NFS share and there's not another example in etc/fs tab for you to follow, then go ahead and use the webmin interface, and that will save you some time looking up that sort of stuff. Okay, so that's how to create or how to configure NFS from the client side of things. Let's talk a little bit more about some of those options that we saw back on this web page under the etc/fs tab. Let's talk about some of these options and what these mean. Well, a good resource for NFS is the NFS HowTo page. And this, if you just search for NFS HowTo in Google, you'll find copies of this all over the internet. This one just happens to be at linux.org. Okay, if you scroll down here, you'll see a table of contents that's quite lengthy. It goes over all about NFS. It talks about how to set up the server, how to set up the client, like stuff that we've already talked about. And then it goes into some advanced things that we haven't talked about, like optimizing NFS performance, or security, and troubleshooting NFS. Okay. And these things are all important. Certainly, security is a very important feature. We talked about just using NFS on a local network. They talk a little bit about if you need to use it on a network that is exposed to the internet, then here's some things that you can do. You can use IP chains and net filter and things like that. We'll talk a little bit more about that sort of stuff when we talk about security later in the series. But for right now, I just want to talk about optimizing NFS performance and give you this as a resource. If you're having trouble with NFS, then certainly go through this troubleshooting section because it's quite extensive and well written, and it'll help you try to solve some of the most basic problems that people run into with NFS. But let's just talk a little bit about optimizing NFS performance. And this is important because NFS already, it's kind of combining the two slowest parts of computing, okay? When the processor speeds today are really fast. Memory speeds are quite fast. And so if we're just doing, using those aspects of the computer, then the computing time is quite quick. When we need to do disk accesses and things like that, then things slow down. If we need to do network accesses, things slow down, okay? And NFS is combining those two slow parts. It's combining disk access and network access. And so NFS could turn out to be a real performance hit. It could end up just killing performance in the network. If we have lots of NFS shares, there ends up being lots of local network traffic, and things could just slow down to a crawl. Okay, so it's important to optimize NFS if you start to see that kind of performance in your system. If you're seeing lots of slowdowns as a result of adding NFS shares and having lots of computers accessing those shares. Okay, one of the most important things you can do is setting the block size to optimize transfer speeds. So if we go back to that other web page when we were looking at the manual, and here's the entry for the Etsy FS tab file, there's two things in here, the R size and the W size for this NFS share that we're talking about. Well, they're talked about in the NFS HowTo page. The R size and the W size are specifying the chunks of data that the client and the server pass back and forth to each other. Okay, so when the client requests a particular piece of data from the server, well, the server actually sends, R size, an R size chunk of data back to the client. Okay, now there's lots of reasons why we would want to send 8 kilobytes of data back to the client, even though the client asked for a particular file that was, just like maybe 100 bytes big. Okay. Why would we send back this whole chunk of data when we're trying to minimize the amount of network traffic? Well, there's a few things going on here. One is it doesn't really cost that much more to send back a big chunk of data versus a small chunk of data. A lot of the overhead is involved on the server side of just finding the data on the disk at all. So once we find the data on the disk, we transfer a whole chunk of it over to the client machine instead of just transferring the small file that they asked for, perhaps. Okay, that's one thing. Another thing has to do with just the underlying network structure. Okay, they talk about in here some tests that you can do to time certain data transfers with varying R sizes and W sizes to determine what the right R size and W size is for your system. Okay, there are also benchmark programs out there called Bonnie Plus, IOZone that will do more extensive benchmark testing and help you tune the parameters of your system so that you get good performance for NFS. And like I said, that's important if you have lots and lots of shares and lots of clients out there that are accessing those shares. It's important if you're in some sort of production environment and you need to have very high quality or very high performance NFS traffic, okay, so that everything is optimized well so that the NFS accesses are as fast as possible. Okay, and these are the types of benchmark programs you should use to test out your computer to make sure that it's optimized in every way. All right, so that's the kinds of things that you can learn from going through the how-to pages, and again, remember that this is a good troubleshooting guide, and like I said, we'll talk a little bit more about security later on in the video series. Now just some final thoughts on NFS before we wrap up. Remember to design your file system with growth in mind. Okay, both growth in terms of the number of clients that are going to access the shares and also in terms of the amount of data that's going to be on the shares. Okay, so say, I have an installation and I create an NFS server here and I decide to put, all the third-party software that I'm going to use in my installation, I'm going to put all that software on this one disk. Okay? Well, then there's all these client machines out here that are going to access that. And as the number of client machines grows over time and the amount of third-party software that's on this disk grows over time, then the network traffic to this disk is going to increase, and this is going to turn out to be a bottleneck. Okay, so when you design your file system, think about how things are going to grow, how many clients you're going to have in a few years down the road, that sort of thing. And if you can, distribute the file systems then across multiple servers to avoid this bottleneck situation. Okay, so if I can have multiple servers out here, like server 1 and server 2, and each one has disks for they both are serving as NFS servers, and they both have disks that the clients are going to access, and we distribute, say, this third-party software amongst those two disks. Then when the clients are going to access stuff, well, some of their accesses are going to be to server 1, and other ones are going to be down to server 2, and so on. And so the load is going to be distributed across multiple servers, and then we're not going to have this bottleneck situation as easily. Okay. That being said, if you don't have multiple servers, if you don't have the resources for that, well, at least have multiple disks. At least distribute the file systems across multiple disks on one server, or across multiple disk controllers on that one server, so that then, again, client access is spread out as much as you can make it, so that we don't get that bottleneck situation. Now, and also, any money you spend on hardware related to NFS is going to pay off. So if you can, put SCSI disks in your system, have good disk controllers, that sort of stuff. Any money you spend on that, that high-tech hardware is going to pay off in the long run. All right, well, that about wraps up our video on NFS. Remember that NFS is used mainly in local networks. We don't like to use it in networks that are exposed to the Ethernet. Remember that the server is responsible for exporting directories to certain clients with specific privileges, and all that is done in the etc exports file. We mount shares on clients either by using the mount command or by altering etc fs tab so that the shares are mounted automatically when the client boots up. And remember, there's the NFS HowTo page out there that summarizes all of this and more, especially has good information on troubleshooting NFS problems, security things, optimizing performance, that kind of stuff. Well, I hope you found this nugget informative, and thanks for watching.